In this warm-up, I wanted you guys to identify the number of valence electrons in each unit. So first question, Adhish, does this periodic table look normal or weird to you?
It looks a bit weird.
Why does it look a bit weird?
Because it's missing some elements.
Yeah, it's missing the entire D block, right? I did that on purpose because I want you guys to notice this. Okay, do you see these A, right? Now go to your periodic table that you should have in front of you. If you haven't printed your reference packet or asked me to print it for you and put it in the front office or have ptable.com up, you need to have one of those up every single class from here on out. We use the periodic table every day, okay? So go to your periodic table, look at your D block, that middle block. What letter do you see next to all those numbers? What letter do you see?
B.
B. So what they are doing, the way this dead white guy decided to name things, okay, was that we would have A groups be our valence shell only. This is the S block. This is the P block. Those two blocks together make up our valence shell, okay? So we're looking at S and P only, and that's because there's 8 electrons in the valence shell, okay? So notice how it goes 1 through 8. It's either 1, 1A, or 2A. But look over here. See how it says 17? Where did those other 10 electrons come from? Where does that 10 come from? Anybody? Why is there 17 instead of 7 as this number? Eva, why is there 17 instead of 7?
I do not know.
All right. So can I help you? Can we walk through this together? All right. Go through. We have, this is the S block, right? And the S block always has how many electrons in it? Ooh, go back. How many electrons in it?
2.
2, right? It always has 2 electrons, right? Where did my pointer go? Hold on, I lost my, there it is. Always has 2 electrons. Okay. This is the P block. How many does it always have?
6.
That's why 2 plus 6 is equal to 8, and this is our valence electron shell, okay? How many electrons does D have? The D is what I took out of here, right? So how many does D have?
10.
Ah, so now let me ask you again. Where do you think this 10 comes from?
From the D block.
Yeah, that we skipped. So the different naming conventions, one of them just numbered straight across 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But then because there's 10 of them, it just kind of skips. So if you see this nomenclature, okay, where it has 13, all we're doing is looking at the ones place to be 3. Because if we're looking at valence electrons, everything here has 1, everything here has 2. So everything up and down, right? Everything in group 1 has 1, everything in group 2 has 2, group 3, 3, 4, 5, 6, 7, 8. So we're just looking at where we are in our valence shell. All right, so we're going to go through this warm up real quick. I'm going to call on people with the wonderful wheel. Thank you, Eva. Does that help? Did I answer your, do you understand now? Awesome. So Genevieve, group 1 has how many valence electrons?
1.
1 valence electron. Beautiful. And then next person, group 2. Charles, how many valence electrons does it have? Charles?
4.
So group 2 is here, okay? So we're counting our valence shell. Remember we numbered our valence shell? 4, 5, 6, 7, 8.
My apologies.
Yep.
I now see that it's 2.
Yes. Did you say 4 because I was hanging out over beryllium?
Yeah, it's just little.
No, so for
Okay.
everyone else, if they don't know what just happened, he read this number right here and gave me that number. This number is the atomic number, which is the number of protons, which I know you know because you've answered that correctly from before, Charles. The valence electrons, we're looking at valence electrons, so only the outside electrons. So that 4 would have been the number of electrons if I asked total electrons, but I asked for valence. So I'm only looking at 1 energy level, the highest energy level. Okay, so there's 1, 2 valence electrons for every, ooh, wow, that was really bad. Can we pretend that didn't happen? Wow, okay, hold on. Better. 2 valence electrons. That was real bad. That was gross. So there are 2 valence electrons. Beautiful. All right, how do I say this one? Wajiha, how do I say this one? Which group is this?
It's 5A.
Mm-hmm. So it's Roman numerals, the same as saying group 5A or group, what else is 5A? Group 15, right? So how many valence electrons does it have, Wajiha?
5.
Has 5 valence electrons. Beautiful. And then in group 17, Milan, how many valence electrons are in group 17?
7.
Yes. So we have 7 valence electrons. So the first step in Lewis structures, which is what we're doing today, is knowing the number of valence electrons, okay? The dots and the lines that we're going to be using over the next week all represent valence electrons, not total electrons. They're only the electrons on the outside involved in bonding. So if there happened to be a multiple choice test for unit 4 at any point, and I asked you, what do the dots on a Lewis structure represent? Faisal, what would you tell them? Or Faisal, why did I say that wrong? My brain just blanked.
Oh, I'm sorry. Are you calling me Faisal?
Yeah,
Okay.
yeah.
Sorry,
Wow.
can you repeat the question?
Absolutely. If on a multiple choice test somewhere in the near future for unit 4, I asked you, what do the dots of a Lewis structure represent? What would you tell me?
The dots are the valence electrons.
Yes, key on the word valence. Do not say electrons. You must say valence electrons, because remember, there's electrons on the inside, like everything in the layers above, and then we're looking at valence electrons that are on the outside, okay? So just remember, view the group numbers like the valence shell, S and P blocks only, okay, for right now. And we're going to be doing valence electrons. The word valence is very important there. That's why you see me writing VE instead of just E like I was before, okay? Scale of 1 to 10, how we're tracking so far. Yes, love it. You can throw up fingers, give me your favorite gang sign. Just kidding, don't do that. I can't promote gang violence. It's totally a joke. All right, awesome. Moving on, so let's look at our first Lewis structure. I'm just gonna talk you through this really quick, right? So the first step is to write the atomic symbol. Actually, I'm gonna talk you through it, but you're gonna talk me through it too. I'm still gonna use my wheel. So what is the atomic symbol for oxygen, Kai? What is the atomic symbol for oxygen?
O.
O, beautiful. Oxygen is O. So if you look at the periodic table block, right? If we go back up and we look at the periodic table block, the atomic symbol is the letter, okay? This is the atomic number. This is the atomic mass. This is the atomic symbol, okay? Everything to do with atoms. Beautiful. Next step is we want to determine the number of valence electrons. So oxygen has how many valence electrons, Audrey? I think you're muted, baby girl. I see your mouth moving.
Oh,
You're good.
okay.
You're-
Hang on, the numbers are really small. 6.
Yes, it has 6 valence electrons. How did you know?
Because it's in the period group.
The group? Yep,
Group
vertical is
16.
group. It's in group 16 or 6A or IA, right? So it's 6 valence electrons. Beautiful. Thank you, Audrey. That was good. All right. Next, okay. We have 6 valence electrons. Now we need to know the number of dots. So we know we have 6 valence electrons, right? So we need 6 dots. Each one is a single valence electron. Now, the tricky part of this is you have to pretend that there's an imaginary box around your element symbol, just like the periodic table block. And you have to put a dot on each side before you double up. Now, this isn't the correct number. I was just demonstrating something there, okay? So when we're looking at oxygen, there are always 4 sides to the atom, right? Like if we drew an imaginary box, we start the dot. It does not matter where you start the dot because atoms are 3-dimensional, right? We're drawing a 2D thing on a 3D space. So it's already not correct. So it doesn't really matter where you start. What's important is that when you start, just go clockwise from where you start. or counterclockwise if you're feeling like a rebel, but just travel around in a circle. Okay. I feel like some of you people would be counterclockwise people. Celine, tell me how you want me to start drawing these dots. We need 6 of them.
I would start from the right side
Yeah, you want
and
to start.
then go clockwise.
So we draw 1 here, and then what would be next?
One at the bottom,
Okay.
one at the left,
Okay.
one at the top,
Yep.
another one on the right,
Yep.
and another one on the bottom.
Beautiful, right? So we end up with 2 alone and 2 next to each other. What I see happen most often is students will do this because they just want to pair them up. This is not correct. So remember we talked about building habits, and I tell you that we're like trying to press the jump. So if you're new to my class, I use video games as reference a lot. Like when you first start a video game, the levels are super easy and you're just like jumping or walking and learning how to do basic things, right? So if we build those habits, when we get to the harder puzzles, we don't have to think about them anymore. So one of the habits I want you to build, like level 1 of a video game, is always going around. Even if you have 8, even if it's a noble gas and we have 8 valence electrons, I still want you to practice going around and clockwise doing it, because then you don't have to remember when can I pair them up, when can I not. If you do it the same way every time, it's one less thing to remember. And the less we memorize, the more successful we are. Processes are how people are efficient. We're going to look at the process, okay? So we're going to do a few together and we're going to review what ions are. So this is where it bogged down a little bit last time because people had really good questions. So if we're going to take a little longer today, this is where it'll take a little longer, but I would love to invest the time if you guys are willing to invest the time, if you have the question. So please ask it, because there were some things I didn't realize y'all didn't get last time. And I want to make sure. I'm going to try to kind of pre-teach some of the things they asked me questions about, but I'm just to let you know, this is where I need you to really pay attention, because if you don't get this, you will not get the bonding part. We're going to look at ion formation, what is actually happening. And then we're going to look at ion bonding. How do they attract to each other? So if we don't know what an ion is, we don't know how they bond. So this is the part where you have to laser focus, okay? So Shinmathi, let's do the calcium atom. Okay, let's do the calcium atom. So what is the atomic symbol for calcium?
Ca.
Ca, awesome. Thank you so much. Next person. Lucas, how many valence electrons does calcium have?
Sorry, my internet's really bad. Can you repeat the question?
Absolutely. How many valence electrons does calcium have?
I'm not sure.
So go ahead and look at your periodic table for me. Do you have your periodic table in front of you?
Is it 2?
Yes, it is 2. How did you get to 2?
I looked at the periodic table.
And it is in group 2, right? So
Yeah,
group 2 is
yeah.
how many was 2 valence electrons. Awesome. As a reminder, guys, if your internet's bad or you're having a hard time hearing me, or even if you just go, hey, I want to listen to that again because I really struggled, remember that I put recordings, and it's usually 5th or 6th period I record because they're not hybrid and it's not like weird to record because people aren't in the room with me. So you guys are usually the recording, by the way, but I have the Zoom recordings folder. If you're ever absent, if your internet's bad and it's kind of splotchy, or if you just want to look at it again, okay? Sometimes just hearing it again helps. So calcium has 2 valence electrons, to recap. So Kira, how do you want me to draw those 2 dots?
I would start one on the top and
Okay.
then one on the right.
Beautiful. So we have one on the top and one on the right. Okay, you don't have to draw them open. I'm just trying to make it a little bigger because the pen is weird on PowerPoint. Okay, so you can draw it a closed like little squiggle, but every time I do that, it thinks I want to click and it's really annoying. So this is how I'm drawing them today. So calcium has 2 electrons. Awesome. Now here's the tricky part. Here's the tricky part. Sonali, what happens when calcium forms the calcium ion? What is physically happening to the atom?
Does it like lose or gain electrons?
Yes, you are losing or gaining electrons, okay? So I'm going to address a question in the chat really quick. when you're drawing the dots, it does not matter what side you start on as long as you go around before you double up. That's the only thing that matters. Okay. So when I drew this, I drew 1, 2. It could start on the right. It could start on the top. It could start on the bottom. It doesn't really matter. Okay. So calcium, we have the 2 dots, and when we go to ion, we're going to gain or lose electrons. So I'm going to go up to this periodic table. So we are looking at calcium here. So when we are ionizing, the whole reason we are ionizing, the only reason an atom does anything, I mean, literally anything an ion does, is because it wants to be a noble gas. It wants to be a cool kid. It wants to have 8 valence electrons. So the atom is going to do the laziest thing to get there, right? Because atoms are lazy. Okay. They're lazier than high schoolers. Just kidding. You guys aren't lazy. You guys work very hard, but they're lazy. So it can either choose to fill its own shell and pretend to be krypton, or it can shirk the electrons it has and pretend to be argon. So it's either going to pretend to be the noble gas 1 energy level below, or it's going to pretend to be the gas at the end of its own energy level. Okay. So it's going to do that by the number of steps. So if we're trying to get to either 8 or 0 in our valence shell, and we have 2 electrons, is it less steps to gain 6 or less steps to lose 2? Sangeet.
Lose 2.
Yes, losing 2 is going to be a lot less steps. So, ooh, we're going way ahead. So when I look at calcium, right, instead of drawing 6 more dots, I am just not drawing dots. I have 0 valence electrons because it's easier to lose 2 than it is to gain 6. Okay, we are losing 2 electrons. So here's the trickier part. Once we understand we're losing 2, I'm going to address the questions in the chat when I finish this thought. So I do see them. Just give me a second, okay? Izzy, we have calcium. We lost 2. But if I just write Ca, it may look like I'm just writing the atom instead of the ion. How do I tell the world that this is an ion and I shed my dots and I'm running around naked?
You put the charge in the top right of it, of
Yeah.
the symbol.
And for ionic bonding purposes, we also put the brackets. So we put a bracket saying, hey, there should have been some dots in this space, but there's not. And then we write the charge. And now here's the tricky part. This is where everyone press the I believe button on the forehead, because we have a unit in mid-April that'll explain why. But when you write the charge, always write the number first. It is a 2+ charge, 2+, not +2. If you write +2, it's an oxidation number, and that's not the same. The charge and the oxidation number are not always the same. So write the number first. Everyone say that out loud to themselves. Write the number first. 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 And if I didn't say it, what do we do? Write the number first. I saw a lot of you mouthing. Yeah, you're just like, oh my God, can you stop now? Yes, as long as you remember to write the number first. Okay, so we have Ca 2+. Okay, why is it a 2 positive charge? Why is it a 2 positive charge, Corey? Why is it 2 positive and not 2 negative? Corey, Bobori, Banana, Fana, Fafori. Are you here? There you are. Corey. Someone text him, be like, yo, Corey, what up?
Oh yeah, sorry. That was
There you go.
I got
You're
up
fine.
to do
It's
it
okay.
on paper so I could write some notes.
You are totally fine. I'm just giving you a hard time. I know that you guys have to get up and do things and you're at home and whatever. So I'm patient. You're good. Okay. So my question is, why is it when we lose the 2 electrons to go from calcium to a calcium ion based on its position on the periodic table, why is it 2+ and not 2 negative? Because we're losing something. So why is it positive?
It's telling you that there's 2 more protons, like the proton.
Yeah. So if we do a quick recap, if calcium, let's pretend we have, calcium has too many. So we're just going to draw the last few. Okay. So every positive charge has a negative charge paired up with it in the neutral calcium atom, right? It's not that no charges exist. It's that the charges are exactly equal. If we're losing electrons, right? If we're losing electrons, we are subtracting or taking away negative charges. So now every proton has a buddy except for the last two, and that's where that 2 plus comes from. The protons are winning by 2, okay? Because the number of protons cannot change, right? Protons are the DNA of the atom. They determine what they are. Neutrons are like the fat of the atom. If I gain or lose 5 pounds, it doesn't change my DNA. Just like if I gain or lose 5 neutrons, it doesn't change my identity because it's not the number of protons. Electrons affects charge. That equates to human like moodiness, right? Positive or negative attitude is basically the analogy I made. If I'm in a crappy mood, it doesn't change my DNA. I'm just not fun to be around, right? So protons have to stay the same. So when we're losing and gaining electrons, we're just losing the comparison between the protons and the electrons. We're either having more electrons than the number of protons we have, or we're having less electrons than the number of protons we have. So that's how we determine charge. Don't get in the habit of saying add and always thinking it's positive. Use the word gain or give, or gain or lose, and it'll help you mathematically in your head make less mistakes, okay? Awesome. I'm going to have someone talk me through sodium. So Akshar, how would you write sodium's Lewis dot for the atom, the sodium atom?
So sodium is Na,
Okay.
and it has 1 valence electron, so we just put 1 dot.
Yep. So you can put it on the front, the right, whatever, but we have 1 valence electron. Awesome. Thank you. So what changes when we go to an ion, Esty? What's changing here when we make an ion?
Oh gosh, I remember.
You're good. Look up here. Look up what we did here.
Well, obviously you put it in brackets and you to show that it's now becoming an ion.
Beautiful. Brackets are
important. It's +1 because the exactly what you said before, like the I don't know how to explain it.
That's okay. So do we write the number or the plus first? What do we write?
You always write the number first.
Yeah, so we'd write 1 plus, beautiful. The reason it's 1 plus, okay, and I hear you thinking it, so can I try to transcribe your thoughts a little bit? I'm going to mind read you slightly. So you have 1 valence electron, which puts it here on the periodic table, right here. So it's easier to lose 1 electron than it is to gain 7. It's less steps. It's the laziest way to get what they want, right? So if we're losing an electron, it means the protons are winning by 1. So we went from 1 valence electron to 0 valence electrons. That's where that 1 plus came from. And that's why it's naked. Does that help?
Yeah.
Okay, awesome. All right. Scale of 1 to 10 on positive ions. And Samir, remind me of the name of positive ions. What do we call them?
Cations.
Yeah, they're cations. And if you want the really stupid, cheesy way to remember that, is that cations are positive, like cats, cat paws, positive. Cations are positive. What do we notice about every cation? How many valence electrons does every cation have? How many valence electrons does every cation have? Saya, not Sia, Saya.
Yeah, I have no idea. I think I missed that part.
Oh yeah, okay, so here we see calcium has 2 valence electrons, sodium has 1 valence electron, correct?
Yes.
Now, calcium ion has how many valence electrons?
0.
Sodium ion has how many valence electrons?
0.
So if it's a positively charged ion, how many valence electrons will it always have?
At least 1.
So if it's a positive ion, remember positive ions are ones that are trying to become a noble gas. So positive ions are the ones that have decided it's easier to lose than to gain, right? So if we're already gaining and losing stuff, we're not going to go halfway. We don't do this whole, hey, I'm going to drive halfway to the store and then I'm going to park because I don't feel like driving the rest of the way. That doesn't make sense, right? You're going to go all the way to the grocery store. If you're making the effort to do the thing, you're going to all the way do the thing, right? So Anytime we're losing electrons, we are losing all of them. So we can look like the noble gas above us. Anytime we're gaining electrons, we're going to gain all of them. So we can have 8. So cations will always have 0 valence electrons because they lost everything, so they could be a noble gas. That's why they're losing. It is the purpose of the whole thing. Everybody is trying to be a noble gas, okay? So this sodium lost 1 electron, and this one lost 2 because they were both trying to have 0. See how that number repeats? So because you had the thought, talk me through aluminum. So aluminum, I'll do the atom for you so you can just talk me through the ion. Aluminum has 3 valence electrons, okay? So what happens when it becomes an aluminum ion?
You put it in brackets
Okay,
and you put Al.
okay.
And are we counting the middle portion for how like far it goes? Yeah, okay. And then I guess you would go all the way to like 8 because it's closer, or all the way to the other side.
So here we have 3 valence electrons. So think about it like a number line. Okay, so if I draw, I'll erase this in a second. Think of it like a number line from 0 to 8. Okay, 1, 2, 3, 4, 5, 6, 7. Ooh, that was really bad. Okay, 1, 2, 3, 4, 5, 6, 7, 8. So we're looking at steps. So if we're at 3, is it less steps to get to 0 or less steps to get to 8?
Less steps to get to 0. Sorry.
Right.
I was just looking at this one and there's this whole like middle section. So.
Oh, you're fine. Yeah, no. Just ignore the middle. We're ignoring the middle. No D block. Yes. So 3 to the left. That's why I drew it that way to begin with, just to remind you guys that you can, like, if you put it in a page protector, like I told you guys last time, you could take your dry erase marker and just scribble all through it. Like, don't look at this. No, right? Yeah. So this would be 3 plus because we lost 3 because we have 0 valence electrons. So everybody that's a positive ion, cations will always have 0. Anions or negative ions, and it looks like onion because it makes you cry, negative, I don't know. Anion will always have 8. That's all I was trying to get across. Okay, awesome. Did that help you understand? Did you get?
Yeah, that helps me understand a lot better.
Beautiful, that's the goal. All right, I'm gonna do fluorine and then I'm gonna have you guys do sulfur and oxygen. Okay, so Darshan, yes, that's what I was trying to explain just now. So he asked if the elements become noble gases, shouldn't there be 8 valence electrons because of group 8? Now, here's the trick, okay? Yes, these naked ions have 8 valence electrons, but they're in the energy shell below where they exist. So when we put these brackets, we are showing what happened to our ions we used to have. So we had 2 electrons, but we lost them. That's why we're showing up naked with no dots, because we lost our electrons. Now with fluorine, we're about to do fluorine. I will do fluorine for you since that's the question, okay? Fluorine has, we'll kind of do it together. I'm gonna come back to this question in just a second. And I do remember where there's still the other questions and I will get to those too. Just give me a sec. All right, Sneha, for fluorine, how many valence electrons does it have? On the periodic table, it's group 17. So how many valence electrons does it have?
It has 7.
Right, so I'm going to draw my 7 dots, 3, 4, 5, 6, 7. So is it easier for it to gain 1 to get to 8 or lose 7 to get to, so Darshan, I'll have you answer this one, okay? Is it easier for it to gain 1 or to lose 7?
Gain 1 to get to neon.
Yes, so now this is when I draw 8 dots because I am showing the universe that I gained an electron, which made me 1 negative. So this space that used to be here is now full, okay? This one is showing that these 2 electrons that used to be here are now gone. If I drew 8 dots, it would look like I went up in energy level, not down. Does that answer your question? So anytime it's naked, we means we lost stuff. Anytime it's full, it means we gained. Okay, so go ahead.
The calcium atom has 20 electrons, right? And then if you take away The
but we're looking at valence electrons. So Lewis dots only look at valence, which are the very outside.
so, but if you were to take away 2 electrons from 20, you'd get 18, right? And
Yes.
then 8.
Calcium ion has 18 total electrons now, which is why it's 2+, because there's 2 more protons than electrons.
So when calcium goes back down to argon, does the outer shell still stay there, and there's no electrons in it,
So-
and that's why they say there's no valence electrons or something?
I'm going to counter your question with a question. If nobody booked a room at the Hilton, does the Hilton still exist?
Yes.
So what's happening is we're talking about which rooms are full or not full. So every shell, all the way up through the 7th energy level, all the way through OG at the very end, exist. They're just not full. We haven't booked anything in them. And hypothetically you could, but we know mathematically because of physics it won't. But we're saying that the rooms are just empty now. So those rooms exist for people to occupy. Those orbitals exist. They're just not occupied right now. Does that answer your question?
Right, so the last orbital of calcium is still there, but there's just nothing in it.
Yes, it's just empty. Perfect.
Okay.
I love that question. Thank you for thinking that through. You made a connection back to a prior unit. Huh. My teacher heart is so happy right now. All right. So what I want you guys to do is we're going to take a break from me talking for just a second. Write down sulfur and oxygen on your paper. Write down sulfur and oxygen on your paper. I'm going to put you in a breakout room. And I want you guys to spend, I'm only going to give you 2 minutes. Like it's not going to be very long, but you're going to give me the atom and the ion for both sulfur and oxygen. And when you're in your room, make sure every person explains it out loud or understands, because when we move on from this point, we're going to get to bonding and I'm going to speak like you understand this part already. And if you don't, you are going to be leaving your classmate in the dust. So it is your responsibilities to make sure everybody in the group understands how you formed these ions and why you drew them the way you did. Okay, does that make sense? No student left behind. Woo! All right. So I'm going to put the breakout rooms. What elements are we doing them for? Anybody? Space bar.
Sulfur and oxygen.
Sulfur and oxygen. Okay. So the rooms are created. I'm going to open them. Go to it when you're ready. Sulfur and oxygen, atom and ion. Atom and ion. Okay, Gus, the wheel has chosen you, Gus. What did you draw for sulfur?
Hey, Miss Longley. So for sulfur, I did brackets.
So we're doing sulfur atom before ion. Let's do atom.
I drew an S.
Okay.
Then I think it was six valence electrons.
Mm-hmm.
And yeah, that's what I did.
Okay, yeah. So we have 2 paired up and 2 not paired up. You go all the way around. You could start it on the right, the bottom, the left, doesn't matter as long as you do it in order, clockwise or counterclockwise, right?
Right.
Right. Sulfide. So since you started explaining it, I'm curious to hear how you did it for sulfide. Remember, in ion, that's the weird way we say anion in chemistry because of a dead one.
Yeah. So brackets and S. And then, so the thing is that since the sulfur thingy is closer to 8 than it is to 0, you do S2 minus.
I love that you said the number first.
Yep, that's me. Go Gus.
Old, reliable Gus. All right, what else do we do, Gus?
Dots, I think.
Yes, so how many dots am I drawing?
2. I don't know how to do the dots.
Okay, so we had 6, right? And you said it was
Yeah.
closer to get to 8. So did you add 2 or subtract 6?
Oh, you added 2.
So if I
So-
already had 6 valence electrons and I'm adding 2, I now have
8, yeah.
So we draw 8 dots. Okay.
Yeah.
The not cool but like funny way to remember this is that positive ions are positively naked. And it just made me giggle, right? Because the word naked. But so negative ions are positively naked, right?
Yeah.
And negative ions are full of negativity, as in their dots are full. So
Yeah.
positive ions are naked with no dots. Negative
Mhm.
ions are full and always dots. Okay.
Yeah.
Thank you so much, Gus.
You're welcome.
All right. Evangelina, talk me through oxygen atom.
Well, the atomic symbol is O,
Okay.
and it has 6 valence electrons.
Right. So it's going to look just like our guy oxygen. Okay. And I'll have someone else talk me through the oxide ion. Oxide. Renee, talk me through oxide, which is the negative oxygen ion.
Okay, so you would put the brackets with the O inside. And so it would have 8 valence electrons because you're gaining 2. And the charge would be 2 minus.
Beautiful. Love it. And you even explained yourself. I didn't even have to ask any follow-up questions. Give me a scale of 1 to 10 how you feel right now, because we're about to talk about how these bond. How do ions get together? How do they decide who is their perfect partner? All right. Keep giving me those numbers. They look pretty good. We'll get ready to put on your thinking caps. Okay. So. Hold on there. So ions always will form 8 and have a full valence shell. When we get to transition metals, there's some weirdness because there can be expanded octets or incomplete octets. And we're going to do that next class. When does an octet act weird and why? But for now, let's pretend that it's always 8. Okay. I'm not going to give you any of them today that are not 8. It won't be until next class. And there's very few exceptions. So it's easier to remember sections. Remember, guys, I told you guys that whenever I studied for my master's, I learned that the chemistry didn't really change much. Like chemistry I teach in IB and AP is very similar to what I did in my master's. It's just you also learned the exceptions. So you learn all of the science up until about now. And then we're like, hey, guess what? We taught you the way everything was, but actually it's not always that way. And here's always the exception. So you kind of learn like the more you know, the more you don't know, and you start learning when do things not follow the rules and why. So we're going to look at the rules first, and then next class we'll look at what doesn't follow the rules and why, but it's very few and it's easy to remember. And I'll teach you ways to remember it. Okay. I said the word octet and apparently I did not define it. Thank you for calling me out. Octet is the 8 valence electrons. So we're looking for an octet. We want a full valence electron shell and we call it the octet rule. So octet is the way we say 8. Yep. It's also the same in music. An octet has 8 musicians. Okay. All right. So everything we're looking for now is an ionic compound. Okay. So if we go back to our composition, matter, substance unit 2. Okay. Well, remember that when we say the word compound, it means that we are creating a new compound that has different properties of the compounds before. So like sodium chloride, sodium metal explodes when it's touched with water, right? Chlorine is a gas, but when we bind sodium ions and chlorine ions, it becomes sodium chloride. That "ide" is the way of saying we're an ion now, and we're writing them next to each other. It means it's a compound, okay? Sodium chloride is the table salt you put in your mouth, and your mouth does not explode and you don't breathe in toxic gas. It's a completely different thing, okay? So we're looking at how they bond and become a new thing. Scale of 1 to 10. Okay. Awesome. I see lots of responses. Love it, love it, love it. Okay. So step 2 to understanding what we're talking about. I'm going to ask some questions that are from 8th grade science TEKS here, where you took that terrible STAR test, because the STAR tests are awful. I'm just going to keep saying that for the rest of my life until someone listens to me. But when you took the STAR test, you had to remember some things. Okay. So Jessica, when we have ionic compounds, and we're looking at sodium and chloride together, we have to remember the law of conservation of matter. What is that?
It's when you like add like two atoms together, two different atoms, and like the reaction happens, the ending result has to have like the same amount of substance as the beginning, because matter can't be created or destroyed.
Ah, you could have been the teacher. That was beautiful. You used vocabulary, you gave examples. So good, maybe so good. So yes, the law of conservation matter says that everything that has existed will continue to exist. So I've been saying over and over, we're gaining and losing electrons, right? So if I gained an electron, it didn't come from nowhere, right? It can't come from the beyond the void, right? Because that's not a thing. So Kate, where did that electron come from? If I gained an electron, where did it come from? Are you here, Kate? Kate, bobate, banana, fana, for fate. Me, my mate. Kate, let's see. Oh, I see you here. Here, we'll come back to her. She must have had to step away for something. I'll come back to her. So, Maheen, where did that electron come from?
I'm not sure.
Okay, so where do we find electrons normally? Oh, I didn't hear anything. I think you hit the space bar because I saw your mic go off, but I didn't actually hear you say anything. I think you talked before it was ready. Where do we normally find electrons?
Like on the periodic table?
Well, the periodic table is where we count them, but what are they normally attached to? Right? Like we're gaining and losing them from the what? What is it called? Protons, neutrons, and electrons together in a group?
Oh, the shell or the electron cloud?
Starts with an A.
Atom. Oops.
There we go. You're good. Electrons are normally on atoms unless they happen to be ejected as a beta particle, right? We learned that in nuclear, but most of the time they're on atoms. So when I'm saying here that I gained 2 electrons or lost 2 electrons, I am directly gaining electrons from another atom. They're coming from somewhere. We are handing them over. We are giving them to you, okay? So we're going to use a funny, so you guys know I like to use drama and like high school drama as examples for things. So let's pretend that Johnny and Susie are a couple, right? And Susie really likes Johnny, but Johnny kind of is like, you could be here, you could not be here, takes forever to text you back, leaves you on red, doesn't respond to your snaps. Like, it's just really annoying, right? You're like, dude, come on, we're a couple, right? So Johnny's not putting in a lot of effort. He doesn't really care. And then Bob comes along that looks basically like Captain America and pays lots of attention to her and talks to her all the time and makes her feel special. What do you think Susie's going to do? She's going to hop ship, right? Because this person's actually acting interested in her. Okay. So this is what happens with atoms. Atoms with low electronegativity, like francium and all those that don't really care, the metals on the left side that could really care less, everything far away from fluorine. They're like, I could have an electron, I could not have an electron, it's fine, like super chill, right, about their electron status, okay? And then another atom comes along that's like dying for an electron, like fluorine, and they're like, I will do anything if you will come hang out with me, right? That electron physically moves from one atom to another. So if I'm drawing sodium chloride, now this is not how you draw as an ion, I'm just going to show you what happens, right? So sodium has 1, chlorine has 7, okay? So sodium is all right, but it's got a very low electronegativity. It's not that attracted to its electron. Chlorine has a very high electronegativity. It is super attracted, hella attracted, right? To this, like Ulrico Suave, talks nice, responds in nice test, tells her it's pretty every day, loves that electron, right? So this electron is actually going to jump ship and end up here. So that's why that we say sodium lost an electron and it's positive, and chlorine gained an electron and it's negative, right? The electron that was lost here is the one that's gained on chlorine. It's a complete transfer of electrons. So on your test, it will ask you, hint, hint, nudge, nudge, poke, poke, pay attention. It will ask you, ionic bonds do what? The answer is going to be transfer electrons. Covalent share electrons. We're not sharing here. Like Susie's like, I am done with Johnny's crap. Forget you. I'm going to be over here with Bob. See you later, right? So the electron physically moves. The reason they bond is because these charges are now, so sodium is now positive, chlorine is now negative, and opposites attract. So they electrically attract to one another because the electron transferred. And that's what keeps them bound, right? Okay. Scale of 1 to 10. I know that was a lot of talking. I normally don't talk for that long at a time, but I got so many questions in the last classes that I had to go back and reteach it. So I just kind of gave it to you. And now we're going to break it down with magnesium sulfide together. Okay. Chlorine is normally 7 electrons, so it would be 1 minus. Now, let me go back to those other questions I had ignored, right? So someone had asked, way back up, let me scroll. Where did it go? It says, what if there are 4 valence electrons? 4 valence electrons is tricky. It could gain 4 or lose 4 depending on what's happening, but it also depends on what it's binding with, because all of these ionic compounds, notice that there's a metal and a non-metal. Metals don't care about their electrons. Non-metals do. So every time we're doing an ionic bond, it's a metal and a non-metal. Since 14 splits that metalloid kind of weird, like we're kind of metals, kind of not column, it kind of has its own unique bonding tendencies. And we'll talk about that during Lewis structures next class. Okay, so I didn't ignore you, but we're going to be covering a lot of that next class. But technically by these rules, it could gain or lose depending on who it's binding with. If an electron with 4 electrons, an atom with 4 electrons is pairing up with someone less electronegativity, right? It'll gain the electrons. If it's pairing up with someone more electronegative, it'll lose the electron. So it depends on its partner is the answer. And I didn't want to explain that until we got to here so you understood exactly why bonds happen. Does that make sense? So it depends on who you're partnering up with. The other part, when it says when you double up, does it matter where you start? When you're drawing these structures, no, it doesn't matter where you start as long as you go around and just keep going around the same way. You could switch directions for some reason if you wanted to, okay? There. So there we go. Now we are good. Did I answer all the questions so far? If I didn't, throw them in the chat. I'm trying to keep track. This is a complicated topic. It seems like it should be simple. And here's the thing, to just do the math for ionic compounds is very simple. To actually understand what is happening is very difficult. This is one of the few times the math is easier than the concept. Okay. One of the very few times. Okay. So last thing, we know this compound is finished because these charges add to 0. Positive 1, oop, look at me. I just broke the cardinal rule. 1 plus and 1 negative add to 0. So therefore this compound is NaCl. There is 1 of each, 1 positive, 1 negative. That's why NaCl is NaCl. That's why we write the compound that way. Okay. If it's pairing up with an electron with less electronegativity, does it gain illusion? So if something, so if I have a carbon, let's use a metal. If I have antimony, okay, it's got 4 electrons and it wants to pair with rubidium, okay, or whatever. It will, if its partner has less electronegativity, the electrons will stay because it's not going to go to an atom that doesn't want the electrons. Now, if I'm going to an atom that does want the electrons, then they will be lost. So whoever wants them more, whoever has the highest electronegativity will keep the electrons. Whoever has the lowest electronegativity will not keep the electrons. Does that make sense? Did I answer the question in the chat? So the higher electronegativity gets all the electrons. The lower electronegativity loses all the electrons. Always, always, always. It's just 4 can go either way. All right, awesome. So let's look at magnesium sulfide. So magnesium as an atom, right, is in group 2. Oh, I hate that bell. So Victoria, magnesium, if I was writing it as an ion, would be what? Let's try to go straight to the ion without writing this first.
Sorry. Oh wait. Or they're two Victoria.
Are there 2 Victorias now? Shut up. That's so, okay. So how about Victoria V, do magnesium, and then Victoria C, which is cope, right? Did I remember that right? So VV and VC, okay. Victoria 1, Victoria Vuong, the one I've had before, will be magnesium, and then the other Victoria, I'm gonna ask you sulfide. I only have 1 Victoria on my wheel. I need to fix that. I need to find a way. Do you guys have a name you prefer, like a nickname or something you want me to put in there and call you? That differentiates you guys? You guys have a preference? I always like asking. I don't like being rude. Like Vicky or a nickname?
No, I just go by Victoria.
Okay. Well, I'll figure out a way to differentiate you for sure. Okay. So Victoria Vuong, Victoria V. How would you write the magnesium ion?
You would write the brackets
Okay.
Mg
Okay.
1 minus.
So,
2 minus.
so
2
magnesium.
minus.
So yeah, magnesium's in group 2, right? So it has 2 valence electrons. So you're saying 2 minus because we're losing, right?
Oh no, it would be 2 plus.
Yeah, because remember when it says we're losing 2, I'm just drawing a small number. This is not true for magnesium. I'm just showing you. When it says we're losing 2 electrons, we're losing these guys. So now there's 2 pluses without a partner. That's why. It's
Yeah. Okay. Yeah.
Yep. Awesome.
So
Okay, Victoria, give me sulfide.
I'm still like a little bit confused on this because like I've been like running all over my room because my cat, she stepped in my watercolor because I was painting and then she got it on my carpet.
I love cats. Fun fact, I got a brand new tiny little 1-pound kitten this weekend because a friend of mine adopted her and couldn't keep her. And I was like, I can't. So I now have another cat. I can't help it, guys. It's a problem. I now have 2 kittens that live inside, 2 dogs that live outside, and a bunch of chickens that live outside, and a bunny. I don't know, you'll hear. If you're new to my class, I love animals. I was a vet in a former life, so yeah. But I actually was late to work last week by like 20 minutes because my first cat, the one before I adopted, crawled into my engine of my car, and I could not start my car until we got the cat out because she crawled underneath. She darted outside because she's only like 2 or 3 months old, so she's not smart yet. So she darted outside and went up under my car, and I was like, well, that's funny. So yeah, cats are a pain. All right, let's see, but they're adorable and we love them. So we have sulfide, which is just sulfur. The "ide" means that we're now the ion. Notice that when we write the compounds, the positive one is always first and the negative one is always second. Okay, so we know that magnesium has to be the positive one. Sulfur is going to be the negative one. Sulfur is normally in what group? Where do you find sulfur?
In the non-metal group.
Yes. So what number group? What number? That's the family. So you identified family perfectly. We're remembering things. What about the group? What group number is it?
It's in group 16.
Yes. So how many valence electrons does the atom have?
It has 8.
Well, the ion will have 8, yes, because we're gaining. Perfect. So you actually jumped ahead. You did great. So it's gonna have 8 because if it already has 6, it's gonna gain 2 more to get full. And what charge does it have?
-2.
Do we write the number or the sign first?
The number, so 2 negative.
Minus or 2 negative, whatever you want to say. So you can say this 2 plus or 2 positive, 2 minus, whatever. Now, last thing we have to charge is that the charges balance, okay? The reason that is because every electron magnesium lost is the exact same electron that sulfur gained. Magnesium handed over its electrons directly. They didn't just come from anywhere. Magnesium physically handed it electrons, right? Yeah. So it balanced to 0. So we know that every electron we lost made it to a home. we're good to go. Okay. All right, scale of 1 to 10. Now we're about to do the tricky thing, and I know that we're running a little over because you guys had so many great questions. If you guys are okay for sticking it out for 5 more minutes, I want to show you one more example because it's tough and you're going to have to know. And if you want to stay after and do more examples with me, we can. But I have one more example. It's going to show you something you have to be able to do on your QCs. And I know we're going longer than normal, but I appreciate you guys sticking around. Because normally we're done by 12:25, I know. Okay. All right. So let's look at strontium bromide. Okay. So if I give you, I'm going to assume you guys know how to do the ions at this point. Okay. So strontium is in group 2. So when I draw it, he's positive. So he's positively naked. We draw SR and I lost 2 electrons. Okay. So there are 2 electrons up for grabs. Okay. I'm just going to draw them down here for later. Okay. Bromine is in group 7, right? So we have bromide, which is the ion version of bromine. It's going to be negative. So it's going to be full because bromine had 7 valence electrons and wanted 1 more to get to 8. So that's 1 minus. It gained 1 electron. Okay. So why is this a problem? Eden, why is this a problem? What are we not doing here? What can we not do?
You can't transfer the electrons to bromide.
Well, you did. So you transferred 1. So the problem here, so we transferred 1 electron. Bromine started here, right? Bromine started like this with 1, and it gained 1 electron. What's the problem?
Oh, it can't gain the other electron.
It can't gain the other electron, but we gave it away. So where did it go? Anybody? Does anyone have a thought? Where did it go? I'll use the wheel in a second to torture someone through this, but I want to see if anyone gets it on their own. Where did it go? All right, Dia, the wheel has chosen you. Are you there, Dia?
I'm not sure. Did it?
I'm sorry, your mic went off again. I heard like a little bit and then it went off.
Oh yeah, sorry, my connections. I'm not so.
Okay, so I think so what's happening here is we only had 1 bromine. So let me give you a scenario. I have 2 tickets to a concert. I need to give both of them away. I give you 1 of my tickets. What do I do with the other ticket? I'm not going to go. Do I just throw it away?
No, you would give it to someone else.
Oh, so what do we do here? What do you think we have to do? Think about it like think about it like tickets.
Give it to something else.
What could we give it to? What's the something else that we could give it to? Anybody? Anybody? Anyone have a thought?
Is it the phosphorus?
No. Try again. I like making you guys squirm a little. It's fun.
To another bromine?
Yes. Who's that? Is that Shanmati? Oh my goodness. Gold stars. That was a sticker moment. When you get here, so new people don't know my weird obsession. I have a weird obsession with like stickers, like good ones. So whenever you get on campus, I've just put a tally next to your name. You get a sticker for that awesome answer. There can be more than 1 atom. So what happened is that the first electron was given to this bromine. The second electron is going to be given to this bromine. That's why there's compounds that have this number. Sometimes the ratio has to be different. So every electron that left strontium has a home. Each bromine can only accept 1 electron, but strontium has 2 to give. Its heart is too big. It needs more people to give love to, right? So it had another bromine, right? And loves both bromines equally. Sorry, it was a joke. It's a kid analogy. You guys probably don't get it. But bromine gets 1 of the electrons. The other bromine gets 2. So the strontium bromide compound has 1 strontium and 2 bromines every time because that's the ratio it needs to exist, right? So one way we can look at that is if we know strontium is 2+ and bromine is 1-, and I draw this little triangle, I know everything has to add to 0. I can't change what I write. I can only change how many. So if I have +2 and -1, I need more negatives. So I write another -1. That gives me 1 strontium and 1, 2 bromines to get to 0. Okay. I know that's real tough. All right. If you feel confident at this point and you feel like you could go do this exact thing on a QC and do it well, you are free to go. If you do not and you want to stay, I will do one more example of a tougher question, the toughest type of question we have, so that way you know exactly what you're prepared for. So that's up to you. You have the Canvas stuff that's due by midnight. The QC I will be putting in tomorrow, so it will go in as a 0 tomorrow if you don't do it tonight, okay? But if you want to go, you are free to go. That is all of the content, okay? I know it took a little longer than normal. Is everyone else here wanting to stay? All right. I'm going to keep on trucking on, but if you weren't paying attention and missed that you could go, that's on you. But you are free to go at this point if you want to. So we're going to do beryllium phosphide, okay? So let me see who's still here. I'm just going to use the participants thing to call on people. Renee, what does beryllium look like an ion?
Sorry, I'm looking at the
You're
table.
fine. No, I know it's going to take a minute. You're good. This is the
What
concept, so I want to make sure you guys have. Yeah, beryllium. It's number 4 on the periodic table.
Oh, okay. So it would have 1 valence electron, so it'd be.
So beryllium's in group 2.
Oh, sorry, 2. So it'd be Be, and then it'd have 2 valence electrons.
Awesome. And then Izzy, give me phosphide.
Okay, so in order to get to that, it'd be like beryllium getting to the nearest noble gas.
Yeah, so beryllium's nearest noble gas is actually helium, which is behind it. So it lost 2 and therefore was 2+. Phosphide is the ion version of phosphorus, okay, which is P. So it's in group 5. So when we make it an ion, is it going to gain 3 electrons or lose 5 electrons?
I don't know, to be honest.
That's okay. So let's do the number line, okay? We have 0 here and 8 here. And we have the 1, 2, 3, 4, 5, 6, 7. Okay. So right now, phosphorus is here at 5. So would it be lazier to move to the right 3? Or would it be lazier to move to the left 5? Think of it like physically stepping.
To the, or move 3 to the right.
Yeah, move 3 to the right. So it's easier to add 3 electrons or to gain 3 electrons, because if it has 5, right, and wants 8 or 0, wants 0 or 8, right? The easiest way to get there, it would be 5 steps to get to 0. It'd only be 3 steps to get to 8. That's why we have the 5 dots. That's one of them's a line. Sorry, I don't know why. 1, 2, 3, 4, 5 dots. It's easier to add 3 more dots. So what we do is if we draw phosphorus, you draw the atom 1, 2, 3, 4, 5. But then we know we want 8, and it's easier to add 1, 2, 3. The other way you can think about it is if you always draw the atom on your paper, think do I have to put more dots or erase more dots? If you have to put more dots, then that's not what you want to do. So you want to do whatever's less. Okay, so we want to put 3 dots because it's less things to do. And that would give us a 3- charge. Awesome. So anyone can pipe up. It's more tutoring style now since it's short, since it's a smaller amount. What's the problem with balancing the charges here? What happens?
The phosphorus is already full, so the beryllium can't give its 2 electrons away.
Yeah, so if beryllium gave its 2 electrons directly to phosphorus, let's draw out the atoms here. And this is why this is the hardest part, okay? If beryllium has 2 and phosphorus has 5, right? Let's say beryllium gives away this and puts it here, and gives away this and puts it here. Is phosphorus even full yet? No. So can this be a 1-to-1 ratio? No, we're gonna have to find a ratio where every time we give away an electron, it has a home. So this is a lot like finding a common denominator in fractions. I know you guys hate that I said that, but it's true. So what number do both of these multiply to? What do they have in common? Anybody?
6.
6, right? So you could be 6 plus and 6 minus. Would that balance to 0?
Yes.
All right, so now we gotta look. If each beryllium has 2 positives, how many berylliums do I need?
Three.
Yes, I saw some people give me fingers. I saw some people write, yes. So we need 3 berylliums, okay? So 3 times 2 plus gives me 6 plus. How many phosphides do I need?
2.
2, because 2 sets of 3 minus. I don't know why it's drawing that as a line. I think because I put the dots too close together. Okay, so that's literally how you would draw the compound. So if I looked at it this way, if we did the same example, right, and I gave you the 2, the 5. Okay, so, oh wait, why did I draw another one? I shouldn't have, just kidding. I got draw happy. So if I did the same thing, I would take this electron and put it here, okay? I would take this electron, put it here, and then this electron would go here, and then this electron would go here. So now every electron that left a beryllium had a home on a phosphorus. We moved the same amount of electrons we gained because we have to gain and lose them from somewhere. So if we were to write this compound formula with just the letters and the subscripts, what would it be? Anybody?
Would it be Be3 and P2?
Yeah, go back. It would be beryllium has 3, so it'd be Be3P2. I just got a great question in the chat. It said, is the one that lost always goes first? Yes, the positive ion is always first. Always goes cation and ion because it's metal. Notice every first element has been a metal. Those will always be positively charged. Even in the D block, when we get there, they're all positively charged. All metals are positive, okay? When they turn into ions. And then phosphide is the non-metal. That's the one that's negative. It will always gain the electrons from the metal, okay? The metal's willingness to give up electrons is why it conducts electricity, by the way, just to link those two ideas together. So this would be Be3P2 because we have 2 plus, 2 plus, 2 plus. We have 3 minus, 3 minus. There's 3 of these and 2 of these. So that's where you get the 1, 2, 3 for the Be3. You get the 1, 2 for the P2. Okay. I have more examples if you want them. I know this is a tough concept. If you want me to do another example, I will. If not, you are free to go. That's your guys' choice. I'm gonna give you guys a second. I want to make sure you guys get it. I know this is no problem.
Thank you.
Thank
No
you.
problem. All right. You guys want to see another one? Essie, do you want to see another one?
Yeah, but can you go back to that and like how would you write that out? Like would you just say Be2 plus Be2 plus Be2 plus and then P negative 3 negative and then P3 negative again?
Yep. So if I asked you to write the chemical formula, that's what this is. It's the actual molecule like structure like you see in chemical reactions. If I asked you to draw the Lewis structure, you would draw this. That's the whole Lewis structure. That's the whole thing. It's obscenely, ridiculously huge. It's dumb. That's why I said this is the hardest one you'll get. The 3-2 split is the hardest one to do. Whether it's 3 plus or 2 plus or 3 minus, 2 minus, when you pair up a 3 and a 2, that's going to be the biggest, hardest one to draw. Okay, let's look at another. So calcium fluoride. Calcium's in group 2, so its ion would look like this. I'm just going to draw the ions for you so you can focus on the other part of the problem. Okay, fluorine is negative, so it has 1 minus. So what would I have to do to make this balance? Because right now, 2 plus and 1 minus leaves me with a positive 1. So how do I get rid of this positive 1?
You'd have to add another fluorine, right?
Yep, so you can either write it underneath or you could write it to the left. It doesn't matter. I'm just going to show you this other way since you asked. Okay.
Okay. Could you write it to the right?
Yes. They're just, as long as they're all connected in a group, as long as they're all together.
Okay.
You want to try potassium oxide? And then I'll see if you got it right. Or do you got it?
I think I'm good. So wait, so for this one, would it be like, what's the other way you told us we could write it? Would it be like CA and then 2 and then F and then
So
-2?
the number on the bottom, are you talking about the subscripts?
Yeah.
The numbers on the bottom are the numbers present, so you're counting, okay? So
Okay.
how many CAs do I have?
1.
Okay. How many Fs do I have?
2.
So
Okay.
you don't have to write the number 1. I just wrote it so you'd know. So you'd write CaF2.
Okay.
Make
Okay, I
sense?
get it now. Yeah.
All right. I'll see you
Okay,
later.
thank you so much. See you later.
Bye.